Make sure we all got paper, pencil out for notes. We don't have our phones out, laptops out. It's all put away. No headphones in. We just got paper, pencil out, ready to take notes. 2.2. Solving inequalities using addition or subtraction. All right. Let's get started. So when we solved equations, whatever we did to one side of the equation, what did we do? We had to do the exact same thing to the other side. That's going to be the same case for our inequalities. Okay? So this is going to be very, very similar to chapter 1. So if you're okay with chapter 1, you should be okay with chapter 2. So just as you use the properties of equality to produce equivalent equations, you can use the properties of inequality to produce equivalent inequalities. Equivalent inequalities are inequalities that have the same solutions. So like I said, it's going to look very, very, very similar to all the stuff we did in chapter 1. So, if I do something to one side of my inequality, I have to do it to the other side. Okay? Let's go ahead and move on. So here's our addition property of inequality. Adding the same numbers to each side of an inequality produces an equivalent inequality. Gives you two examples right here. Negative 3 is less than 2. That's a true inequality, correct?
Yes.
Yeah. So if I add 4 to both sides, negative 3 plus 4 gives me 1. 2 plus 4 gives me 6. Is that still a true inequality? 1 is less than 6. Yeah. So if I add the same thing to both sides, I still get a true inequality out of it. That's essentially what this is saying. Okay? Negative 3 is greater than or equal to negative 10. Add 3 to both sides. 0 greater than or equal to negative 7. Still a true inequality. Does that make sense? Whatever I do to one side, got to do it to the other. Everyone got it?
Yes.
Perfect. Let's move. Going through this quick. Very similar to chapter 1. Example 1. Solve x minus 6 is greater than or equal to negative 10. Graph the solution. X minus 6 is greater than or equal to negative 10. So when I'm solving my inequalities, my goal is still the same. To try to isolate the variable by itself on one side of the inequality. So right now, is my variable by itself on the left side of the inequality? No. What number is with it? 6. What's the operation going on between x and 6? Subtraction. Subtraction, right? So what's the... Hold on. What's the inverse of subtraction? Addition. So what am I doing to both sides? Adding 6 to both sides. Very good. If I add 6 here, it'll cancel out. Like we said, if we do one thing to one side of the inequality, I got to do it to the other. What's left on the left-hand side? X. Greater than or equal to negative 10 plus 6? Negative 4. Is x now by itself on one side of the inequality? There's my answer. Everyone good with that? Nope, I'm not kidding. So this answer represents all the solutions that are a solution to this inequality. How many solutions do I have here? An infinite number, right? Because it's all numbers that are greater than or equal to negative 4. Our numbers keep going forever and ever and ever, so I have an infinite number of solutions here. This inequality just helps us represent all those solutions. Okay? So let's graph it. Graphing just like we did yesterday. What number is my circle going to go on? Negative 4. Everyone okay figuring out where the circle goes? Okay. Is it going to be an open or closed circle? Closed. How do we know it's closed? It's got the line underneath my symbol. It's or equal to. That means that number, negative 4, is a part of my solution. So I've got a closed circle at negative 4.
And then you go to the left side?
You go to the right.
Which way am I shading?
Right.
Right. because it says it wants all numbers that are greater than or equal to negative 4. So the numbers that are greater than negative 4 are to the right of negative 4. Does that make sense? So I'm shading to the right. Now that graph is representing all the solutions of this inequality. Any questions on example 1? How do we feel about that? Good, good. Like I said, very similar to chapter 1, right? Okay, can I move on? Let's go through these examples a little quicker. Now that we kind of have the idea of it. Are we okay with graphing, by the way?
Yes.
We all understand where to put the circle? Determining if it's open or closed, and determining which way to shade. So, for time's sake, are you guys okay if I cut the graphing portion of this and just solve the inequalities?
Yeah. Graphing for number 3.
Yeah, I can do that. Yep. We're okay if we cut graphing everywhere else, though?
Yes.
Okay, perfect. Number 1, how do I get b by itself? Add 2 to both sides. B is greater than, what's negative 9 plus 2? What?
11.
Nope.
7.
Nope. Negative 7, very good. Is b now by itself? Yes, it is. There's my answer. There's the inequality that represents all my solutions. Questions on 1? If it does tell you to graph it, I still want you to graph it on your assignment. But like I said, for time's sake, we'll cut it out for now. Number 2. How would I get m by itself here? Add 3 to both sides. M less than or equal to 5 plus 3? 8. Any confusion I need to clear up so far? Any at all? And number 3, how would I get y by itself? Add 1/4 to both sides. I'll cancel out on the right. 1/4 plus 1/4 gives me 2/4, which reduces down to
1/4.
1/2, right? Not 1 1/2, but 1/2. So I get 1/2 is greater than y. Y is now by itself. Okay, I have a request to graph this one, so I'll graph it. Okay, where's my circle going to go?
To the
Well, what number?
left. 1 and 2.
It's going to the left.
So what number is that?
0.5.
0.5 or 1/2, right?
Yes.
Which is halfway between what? 0 and 1. Very good. Is it an open or closed circle? Open. There's no line underneath my inequality symbol. So I have an open circle halfway between 0 and 1. Does everyone see that? Now be careful where you shade here. Which way am I shading?
To the right.
To the left. Very good. Remember, we've got to read it from the variable standpoint. I read it from the variable standpoint. It says y is less than 1/2, correct? So all the numbers that are less than 1/2 are to the left of 1/2. So we'll shade to the left. Questions on that graph? How are we feeling so far? Good? Good. Okay. Same thing, now we're using subtraction. Subtracting the same number from each side of an inequality produces an equivalent inequality. Okay? Same concept here, we're just using subtraction instead of addition. Just like with our equations. If I subtract the number from both sides of an inequality, it still produces a true inequality. That's what this slide is saying. Do I need to spend a lot of time on this slide, or are we good? We good? Okay, moving on. Flying through these notes. I like it. Okay, example 2. I've got y plus 8 is less than or equal to 5. Raise your hand if you can help me out on this one and tell me how to get y by itself. Very good. Subtract 8 from both sides. Y has 8 on the same side of the inequality. The sign between them is addition. Inverse of addition is subtraction. So we're subtracting 8 from both sides. 5 minus 8?
-3.
-3. Am I moving too fast for anybody?
Nope.
Questions on A? Letter B, raise your hand if you could help me out on this problem.
Add 1.4 to both sides.
Add 1.4?
Subtract.
Subtract. It is a positive 1.4. So in order for it to be eliminated from that side, I need to subtract it. So it'll cancel out. Everyone good with that? -8 minus 1.4 gives me
9.4.
-9.4 is less than m. Is m now by itself?
Yes.
There's my answer. Be careful on this one as well. Which way would I be shading in this case? I'd be shading to the right of -9.4 because it's saying m is greater than -9.4. Always read it from the variable standpoint. Okay? Questions on example 2? Yep.
So, if the variables on the right, don't we shape it?
No, that is not the case. We're reading it from the variable standpoint. So instead of reading it from left to right like I would here, because the variable's on the left, I'd say y is less than or equal to -3. Right here, right? Over here, I'm going to read from right to left because the variable's on the right. M is greater than -9.4. So let's look at a number line. Where's my circle going to go?
In between 10 and
In between -9 and -10. Is it open or closed? Oops. It is open. And like I said, it says m is greater than or equal or greater than -9.4, right? So the numbers that are greater than -9.4, is that to the right or to the left of -9.4?
To the right.
To the right. Numbers that are bigger than -9.4 to the right. Does that help at all? Okay. Okay, we'll get some more practice here on the next slide. Questions on example 2? Okay, let's go through these pretty quick. K plus 5 is less than or equal to -3. Raise your hand to help me out. Go for it.
Subtract 5 on both sides.
Very good. Subtract 5 on both sides. K is less than or equal to -3 minus 5. -8. So raise your hand if you can tell me which way this graph would be shaded.
To the
Raise your hand. Very good. It's be to the left because it says K is less than or equal to -8. So I want all values that are less than -8, so it'd be to the left of -8. Does that make sense?
Yes.
Okay. To the left will always be less than that number on a number line. To the right will always be greater than that number on a number line. Okay? Number 5. Raise your hand if you can help me out here. Yeah. Very good. Subtract 1/6 from both sides. 5/6 minus 1/6 gives me 4/6, which reduces to 2/3. Always, always, always write your fractions in simplest form. Always. Is Z now by itself? Yes. Raise your hand if you can tell me which way I'd be shading this graph. Read it from the variable standpoint. Read it from right to left here. What's it saying? Z is greater than or equal to 2/3, right? So would greater than be to the right or to the left? to the right. We want all numbers that are greater than that number, so that'd be to the right of that number. Okay? And number 6, raise your hand if you can help me out. Very good. Subtract 0.7 from both sides. P is greater than, what's negative 2.3 minus 0.7? Negative 3. If you put negative 3.0, that is also correct. Which way would I be shading this graph? What? Not left. Be to the right, because P is greater than negative 3. Want all values greater than negative 3. Questions on these 3 examples? We good? Here you go. We're done with the notes for today. Page 71, numbers 4 through 26, evens. This will be due Monday. Oh, wait. You guys aren't in school Monday, are you?
No. Tuesday.
Wow. This will be due Tuesday, which is the 20th. Yeah. Wow. Due Tuesday the 20th on Canvas.
You still gotta be at school though, right?
Yes.
Got 27 minutes. You can knock this out.
I know, right? So get this written down. Get the correct heading on your paper. Like Coach Kilby said, you guys got plenty of time to knock this out in class, hopefully. So make sure you're working diligently on it. Are there any questions on any of my notes before I end the recording?
Coach, can you go back a slide?
Yeah,
Still
yeah.